So today we're going to look at two types of analysis in terms of Windflow design. We are going to look at Autodesk Flow Design, which we are going to use the Revit plugin, and we're going to look at Autodesk Project Vasari. Now, we're not looking at, there is another Autodesk product called Autodesk CFD, Computational Fluid Dynamics, and this is a much more advanced simulation software for fluid dynamics. Now, it's beyond the scope of this module really, because it's quite a complex piece of software, but I did have one student last year who actually learnt that software themselves and got some really fantastic results, because that allows you to simulate airflow inside a building. The airflow we are going to look at today is about external site wind flow. Okay, so the software that we're using they're slightly simplified versions of computational fluid dynamics. So they're not the sort of full computational software. Okay, they're deliberately simplified to make them more usable for designers. Okay, rather than being the sort of full simulation engines that your engineers or your aerodynamicists would use. Okay, and we're going to have a quick look at both of them, and then it's up to you which you prefer to use, because they've both got pros and cons. Okay, so the first thing to say is the Autodesk Flow Design. You need to download that for free from your normal Autodesk education site. What it then does is it downloads it as an application onto your hard drive, which will come up as Autodesk Flow Design, but also in the background it should install it into Revit as a plugin. Okay? And today we are just using the plugin, so we're not using the standalone Flow Design software, we're not using it. Okay? We will then use the wind tunnel in Autodesk Project Vasari, and you'll see from the demonstration today that there are kind of good points and bad points to both. The other thing that I think is probably important to note is, as I keep saying throughout this course, the software is constantly changing and the software is improving. Now, last year Autodesk Flow Design was called Project Falcon, and it was a kind of beta software as a plugin for Revit, and it didn't really work very well or very often. So we didn't use it last year, but I've been trialing Autodesk Flow Design and they seem to have fixed some of the technical problems, so it does now work. But I think what I would say, to be honest, with both of these softwares is they will continue to improve over the coming years, but obviously we just have to start using them as they are. So we're going to head straight into Revit, and we are going to start with Flow Design. Okay, now you'll have to bear with me again, because I'm using this screen only, the resolution's not quite right, so it's all a bit squashed, and I'm probably going to get a sore neck from looking at that. Okay, so I'll do my best. So here we are, we're in Revit, and I've opened one of our site models with one of our conceptual buildings in it. Okay, and if we notice along the top, we have this Flow Design tab, and this is activating the Flow Design plugin for Revit. Okay. Now, just going to do a few things before we start using the Flow Design. Generally, there are just a few settings to help things work slightly better. First thing is just to switch your shadows off. Okay, so I switched our shadows off. They generally they don't help in Flow Design. And if we also go into our sun settings, let's just check we've got that on still, and let's just go into our graphic display options, And what we want to do in here is, we've already switched the shadows off, we want to switch off ambient shadows. Okay, so we go back to a more simple type of view. The only reason is because those shadow effects, they mask some of the results you get from the Windflow, from Flow Design. Okay, so we've got our site there, and what I'm also going to do for now is in our properties for the view, I'm just going to switch off the section box. Just zoom out of it. And while I'm on, I'll just hide those lines there. Okay. ZE, zoom extents. So there's our site. Okay, we're just viewing it in a 3D view. And what we can do now is start to activate Flow Design. So we just click on Start. And just give it a moment, and it will start running. Okay. It does slow down Revit quite a lot while it's working. In fact, I think that's crashed it. Let's just start it again. It was working fine yesterday. Last year, when we tried to use Falcon, we abandoned it in the end because it would only work about 50% of the time. But this certainly is. When I've been testing it, it's certainly more stable than Falcon. Okay, so it has started, and let's just look at some of the settings. Okay, I'm just gonna pause. Top left here. I'm just going to pause that simulation for now, because what it will do is every time you change a setting, it will be re-simulating the wind, and that will just slow us down. Okay, so we've got wind direction, we've got wind speed, wind profile, the resolution, so how detailed is it simulating the wind flow, the wind tunnel size. Now this is important because it will start with quite a large wind tunnel, and you can shrink that down to speed things up. 2D simulation or 3D simulation, plane orientation, plane position. So let's start with plane orientation, and let's click on that, and if we select the horizontal plane, it will now put us into a horizontal wind simulator. Okay, and if we just resume, we should now get a wind flow in a horizontal plane across our site. Okay. If I just go into a top view, so we're getting a wind flow, and we've got a key. That's our key, but it's teeny tiny, hiding in the top corner. Now the easiest thing is just to make sure you've got the right scale for your drawing. So I'm changing that to 1:500. Let's give that a moment. Okay, so now, what I'll do, I'll just drag that key, bring it a bit closer. Okay. Zoom in a bit. So what we've got, we're simulating a wind flow across that site, And the color coding, excuse me, is giving us the wind velocity. So, if we just have a look, the dark blue is 0 meters per second. And then we move through the color scale up to 53 meters per second. So, what you can, if I just pause that, and we'll start it, we'll just change the wind velocity actually, because it's set a little bit too high. So if I go up to the wind speed here, top left, okay, and you see that it's quite slow, but it is actually simulating that wind coming through, okay? And you notice we're getting these sort of speeded up areas of wind off the corners of buildings. We're getting these slower areas indicated by the dark blue. We're getting this sort of turbulent flow here, and we're getting this accelerated airflow in the red. Okay, so although it's a sort of it's not a full computational fluid dynamics simulation, it is simulating the effect of those buildings on that wind flow. Now I think it's partly running through, running so slowly because as usual I've got my Adobe Captivate software running, which is taking quite a lot of my computer's hardware. Normally it's a much quicker flow than that. Okay, let's just go and play about with the wind direction. Okay, so at the moment you can see it's set at 34 degrees from north. Let's just drag that round and hit close. And then it will slowly start to change that wind into the different direction. Okay, it's just starting to catch up. Okay, so you don't normally have to wait so long for it. Okay, we're now starting to get this wind more from the south, and you can start to see the sort of impact that the buildings have on that. Okay, wind speed. We can slow down our wind speed or speed up our wind speed. Okay. Now, what flow design doesn't have, which Vasari does, which we'll show you in a minute, Vasari has a nice graphic where it shows you the windrows for your site. And you can pull that wind direction, that wind velocity in relation to that windrows. Now, flow design doesn't immediately have that, and so when you're playing about with the wind, it can feel a little bit kind of random what you're doing. But what you need to do is keep looking at the windrows. So I'm going to go through some of the tools. And then we'll move into Vasari, look at it in Vasari, and then I'm going to talk about some of the principles about how you'd actually analyze the wind flow on that site. Okay, let's go now to our tunnel size. I'm just going to zoom out. Oh, in fact, I'll just pause it while we do that. ZE, zoom extents. Now you can see that we're simulating far too much here. We don't need to simulate all of that area. So if we just go to our tunnel size and just make this a bit smaller. Sorry. I'll have to start Revit again. It does sometimes crash. I mean, I was running it for several hours yesterday and it crashed once. I'm not having a good computer day today. Okay. I mean, I suppose that the nature of these Autodesk beta products is what they're saying is they're not fully sorry, can you not talk when I'm talking? They're not fully tested products, but what Autodesk do is say, we'll let you have them to play with, even though they're not fully commercial products yet. And I suppose the sort of downside of that is you have to accept that they're not always 100% stable. Okay. Switch our shadows off again. Go into our graphic display options. Switch off ambient shadows. And let's start flow design again. Just while that's working, the sort of obvious benefit of flow design is that it's embedded into Revit. So you can be working in your Revit model, you can activate the flow design tab, and you start to get wind simulation immediately in Revit. You can then export the images from Revit as you would normally. So it does have that quite significant benefit. Didn't work, did it? The slight downside with Vasari is that you do have to open the file in Vasari, but as we've said before, you don't have to import. Vasari will open the Revit file natively. Okay. I'm sure at the minute you're not very impressed with flow design. I'm not very impressed at the moment. I was quite impressed yesterday. I mean, it probably is struggling because my machine's slightly compromised at the moment. Okay. So, let's go back. Let's go back and change our plane orientation. Let's go back into a vertical plane. Okay. So there's our wind simulation. In a horizontal plane. Okay, you can see the sort of effects. Your plane position, you can drag here. So you can vary its height. So you see I've dropped it down there on the site. Okay. Because you're in Revit, all your normal view controls are exactly the same. So you can click onto a top view, click onto a 3D view. Okay, so that's all unchanged. Wind speed we did. Wind profile, just have a look at that. Now, this is a parameter which does not exist in Vasari. And what the wind profile is doing is it's letting you put a wind speed factor depending on your altitude. So, for example, we know that in cities we have slower wind velocities at ground level. So here we've got a wind speed factor, so a multiplier related to building height. So here we go from 0, 40 meters, up to 360 meters. And we can apply this wind speed factor. So if I just click on apply there, and then close, what it is now doing is it's applying this factor that will have the wind moving slightly slower at ground level and higher wind speed higher up above the ground plane. Okay. I'm slightly wary to mess with that tunnel size because it crashed it last time. We'll come back to that. You can change your color coding under your key here. You can change from velocity to pressure. So if you want to actually have the pressure of the air rather than the speed of it, you can change that. Just put that back. You can, just zoom in a bit there, you can actually add a wind probe if you want. I'm not sure for our purposes this would be necessary, but if you wanted to, you could add a specific wind probe which will give you a measurement of the exact speed at that point. See if that works. So that should have added a wind probe onto that point there. Not sure that it did. So I don't think you really would need that level of detail, to be honest. Okay. Resolution is the sort of the quality of the simulation. So for that you can just play about with how fine, how detailed you need that simulation to be. Okay. Now let's have a look at, let's just zoom out. We'll just now look at changing the plane orientation. And let's put it into this vertical plane. And what I forgot to do here was to just, it's often, well, I'll leave it for now, but often it's beneficial to switch off the section box. Okay, because it can slightly confuse what you're seeing. But for now, I'll just leave it on. Let's just pan around a bit here. So we're now simulating that wind in a vertical plane. If I just click on the left view, it's probably clearer. Let's just change our scale back to where we were before we crashed. So those of you who were in the Principles of Building Physics lecture on Friday with Abigail Hathaway, you'll notice that when she had that image of the sea spray blowing off the coast, we're seeing the kind of the simulation of that here, where I'll just drag that key in a bit. But what we're seeing is that wind flowing over the building. We're getting that speeded up air above the building, and we're getting that slower velocity behind the building. Okay. Now, the reason I say often it's a help to switch the section box off is because if you leave the section box on, the flow design simulator doesn't recognize that. And sometimes it will be simulating the wind flow effects of parts of the model that you can't actually see because you've cropped it with the section box. So I generally find it's best to start with the section box off, start to get some results, and then you may want to switch the section box back on. So I've switched it off there. Okay, let's just change our position. Okay, so I've just changed our plane position there, so it's now projecting that wind over the arts tower. And if we just click on resume, so as I was saying, in flow design, you don't get that windrows showing you which direction the wind is currently being simulated from. So, for example, when we're viewing there, we're seeing the effect of that wind in a vertical plane, but it's very difficult to actually know which direction the wind's coming from. The only way you can tell is by clicking on the wind direction and actually manually changing that. Okay, so that is slightly better in Vasari. Now, in terms of exporting, if we just pause that, it's quite easy in Revit, just as we did before with our solar studies, is to go under the Revit button, export, images and animations, image. Okay, and as before, you can choose the resolution of your image, visible portion of the current window. Okay. And it will just export a JPEG of the of what you were rendering there in the screen. Okay. So I've opened Vasari, and we're going to open the same model in Vasari. It's a Revit file, and you always get this warning saying that you won't have the full functionality because you're opening a Revit file in Vasari, but that's okay. So we've got our same file in Vasari now. Let's close that down. I'm just going to switch off the section box again so we can see our full model here in Vasari. And again, I just want to hide those lines. Okay, so similar in Vasari, open your Analyze tab, and we have a wind tunnel button. And what Vasari then does, it takes us into the wind tunnel simulator, and it's kind of like a different environment. So it opens it in a new window, and what you probably will find slightly odd is that the tools are slightly different from Vasari and Revit. So the other advantage of flow design is the way that you zoom, the way that you pan, is all exactly the same as Revit. Now, in the wind tunnel in Vasari, it's not. So you have these controls at the top here for zooming, panning, orbiting. And your normal sort of scroll wheel, shift and scroll, they all work slightly differently. Okay, so there's our site. We are simulating a wind, but what you can't see because it's currently below the ground plane. Now, if we just come over to the left, we have a whole range of controls. So the first thing we're just going to do is drag that plane up a little bit. Okay, and we've got all these different settings. I'm just going to switch off displace values in 3D for now. And so we get the same idea of a wind simulation, but in Vasari it's a little bit easier to play about with the settings. So all of those sliders, okay, are along the left. And as I was saying, the kind of slightly easiest thing in Vasari is that you do get to see the windrows. So when I change that wind direction, you get a very sort of easy visual means of understanding what it's doing. Equally, when you change the wind velocity, look at the ball, the sphere here. You get a very sort of intuitive visualization of what we're actually seeing. Okay, let's just go through some of the other settings. Again, you can pause it. So you can pause the simulation up here, which is useful because then if you want to take a snapshot, it's not moving the wind about. Okay, let's just set that going again. 2D or 3D, generally I find working in 2D is a lot easier to understand. You can play about with the 3D, but I find it doesn't add a lot of meaning. You've got your velocity here. Again, you can choose wind velocity or air pressure. So now we've got air pressure rather than wind velocity. Okay. Detailed wind analysis. It just pulls you up the local climate data and it shows you the windrows for your site, which is all very helpful, just to understand what the wind does, and I'll come back to that in a moment. Analysis grid settings. You can change all of the sort of size and extents of that grid. You can play about with that. The position of our slice we already mentioned. So very easy to drag that about. And slightly more intuitive in a way, if you want to change the plane direction, you can just simply select using this drop-down menu here. So as you can see there, I've changed it to a vertical plane. Now, one thing you'll notice is it's very windy under the ground in Vasari. Notice that? We're getting a lot of wind below the ground. Vasari does not register topography. Okay? Bit annoying, but it doesn't. Flow design, in Revit, it will pick up the topography. Okay? So it's slightly odd that it will show you a wind below ground. And there's no way around that. Unless you were you'd have to remodel your topography as a sort of mass. To be honest, I mean, the easiest thing to do is just to, when you're ready to take an image, just to crop below ground. Okay. Animate, cycle forward, backwards, just the way it animates the wind flow simulation. Display coloured cells, flow vectors. So these are all, they're a bit small to see at the moment, but these are all little flow vectors showing you the direction. Put that back. You can show the grid lines, or you can hide them. Displace in 3D, see what you think, but it will take the wind speeds and it makes a sort of 3D plot. Sometimes you can get some quite effective graphics out of that if you're trying to explain. And then if you can play with the setting. Oops. Stick. So you can play about in here with the proportion of displacement. Okay. I'm kind of rushing a bit now, but 3D volumetric. This will slow it down, and I've not found it to be that effective, but it tries to give you a kind of 3D overall view. Okay, and you can choose flow lines, you can choose ISO surface. So I think that it's probably a bit more than you need, to be honest. I'm just going to switch that off. Okay, data display. You can choose pressure or velocity, as we said before. You can change all of your color scales. Okay, very straightforward. Okay, so you can play about with the colors. You can change the opacity of your colors. And then you have a range of graphic display options here in terms of, do you want to see the outlines of your masses? Do you want to see the surfaces? Do you want to see that local windrows? So you see that I'm switching that on or off. Oops. And this one I find is quite useful. If you switch on the local windrows, rather than the wind frequency chart is a little bit difficult to see. If you switch on the windrows, if I just orbit slightly, if I just go back into a horizontal plane, actually. Okay. So this I find is quite effective, because you can, when you move that wind about, this is giving you the windrows for that site. So in terms of how you would simulate the wind on that site, now obviously for any given site, the wind is going to move, and it will be different throughout the year. So you can't simulate just for one snapshot in time. What you need to do is you need to sample. And the normal methodology would be to take take some samples at the highest velocities on that site. So for example, let's change our angle and let's put our wind here into this high velocity. Sorry. So we put that into our high velocity point on our windrows, and then we look at the effect of that wind on our site. And you're looking for if there are particular kind of problem areas. Are you getting particular sort of acceleration of wind, causing problems at the pedestrian level? We're all familiar with what happens at the bottom of this arch tower on a windy day where the wind gets accelerated. So the kind of thing you might be looking for is, if we're looking at the sort of wind distribution here, we're looking at these accelerated zones because they give us a potential warning that we're getting very high wind levels. Now what you could then do is change your position. Change your wind angle and take it to another point, and again set that velocity onto one of the sort of worst case scenarios on that windrose. Now there's no point simulating, if you just keep an eye on what our wind is doing, there's not a lot of point on this site simulating a wind from this direction at that high velocity, because we know from the windrose we don't get that wind condition. Okay? So what you want to be doing is simulating velocities and angles that are kind of realistic for that site. And this, I find, is where Vasari is better, because it's so much easier to visualize what you're doing. If you were working in flow design, then what you would need to do would be to have the windrose on a separate image, and when you're inputting the direction and the wind velocity, you would need to be referring to the windrose just to make sure that you're putting in realistic wind conditions. Okay, but I quite like the fact that in Vasari you can just immediately see what you're doing. Okay, now Vasari, as we've mentioned before, it does not have a sophisticated means of outputting. You simply have to grab the screen. Okay, very, very basic. You have to do a screen catch, and that will catch that screen, and that's all you can do. Okay, so fairly sort of simple in terms of exporting your results. Okay, right. I'm aware that I've sort of rushed through that a bit because of the technical problems earlier. But I think what you'll find with both of the softwares is when you sit and try the different settings, you can make these, you can make the graphics kind of appear how you want, and you can get some meaningful results. The thing to avoid with them is to try and do very, very complex analysis. So, for example, in the past I had a student who was trying to use Vasari to simulate wind flow through a building, and the software's not really designed for that. It's designed for a more urban scale flow around buildings. Okay. Right. Any questions before we take a break? Yeah.
Sorry, how do you export images?
You just have to do a screen grab. So for example, on a PC, I use this, very basic, I use this snipping tool, and you just have to capture your screen.
And in Revit there is no to export as a render?
In Revit?
Yes, as a render, not as a second image?
In Revit there is a render option. Oh, I've closed it down now. I find it's temperamental. It doesn't always work. What you can do in Revit is you can just save as an image, which is slightly easier. But what you can't do is kind of save the image as a view within Revit. So both in Vasari and in Revit, once you're in the wind tunnel, you can't do anything else until you come out of the wind tunnel. So you see here, we can't use any of the other Vasari tools until we quit out of the wind tunnel.
So what about the resolution of the picture? If we took a picture of that,
Well, it depends on the resolution of your screen. Yeah. But I mean, normally, sorry, can you not talk? Sorry. If your screen is, this runs at 1600 by 900 pixels, normally that's adequate, bearing in mind that you're then likely to be taking that image and shrinking it down in a report. So it's okay. I mean, in Revit, you can set the resolution, but in Vasari, you just have to capture the screen. Yeah.
And I can catch the point that this Vasari could not modify the topography.
Topography.
So topography of this plane only a plane, not.
Yeah. So in flow design, in Revit, it will register topography. In Vasari, if I go back to a vertical plane, it does not register the topography surface.
Actually, maybe the Windflow difference on different topography.
Well, it is.
So it may be the result is maybe quite different in Revit and
It could be. I think what you generally find is, as long as you ignore any simulation below ground, it's not so accurate that what's happening down here is actually affecting what's happening up here. If you put your buildings on the ground on level 0, then Vasari will not project any wind below level 0. But it is just a limitation. A few students last year in Revit, they built a 3D mass, which was exactly the same as their topography, and then you can bring that 3D mass into Vasari. But I think, the thing is to recognize there's no point having a hugely complex model for a simulation which is a sort of basic initial ideas simulation. And the other thing to understand is this is not as architectural designers, you will not be performing sort of advanced wind flow calculations or simulation. So you do this to inform your design at an early design stage, but you would not be using this, for example, to design a high-rise building and to verify that there are no wind flow problems, because that would be done by the engineers. Okay, and that would be done in a much more sophisticated package. This is a front-end design tool for architects. Okay. Okay.
Sorry.
Yeah.
The smoke design, I can't see it in my Revit software.
Have you installed it?
Yeah, the flow design, and you can open the Revit. I can't see it in my.
Have you installed flow design?
Yeah. How to install?
I'm not sure at the moment. I installed it a few weeks ago and it just went into Revit.
Yeah.
I'm not sure. I'll have to look into it. Okay.
And this function can not work on my the flow.
The wind flow?
Yeah.
Okay.
It's that one.
Yeah. The wind flow, it will depend on your graphics card, and if you're using a Mac running Windows, it may not work. As I mentioned in the email last week, I am getting Vasari installed on the 2 machines on floor 18. Okay, so that's all. You'll just have to make do with those if it's not working on your computer. Okay, we only use Vasari for the solar radiation and for the wind flow. So I think we just have to make do. The University Computing Services will not install Vasari because they say it's a beta software, and so they won't do it. We've tried, and they won't have it. Okay. Yeah.
Sorry, I need to know the more benefit about the velocity and the pressure wind in our design in the future, because it's important to know the direction of the wind.
Mm-hmm.
So is this useful? This tool is going to be useful in the future in our design?
In terms of climate change,
Yes.
you mean?
Yeah. About the velocity of the wind and also the pressure of the wind in our building.
Yeah.
So is it this tool is going to be useful for our designs in the future?
Yeah, I mean it's yes. You can't in this software you can't put a future climate you can't put future climate data into the software yet, but potentially with global warming, the wind effects will become more and more significant. So as designers, we will have to be a lot more aware in the future about the effect of wind. And we are having higher incidences of hurricane situations, of high wind flow. So yeah, it will become, in certain climate zones, it will become a more significant matter. The other issue to bear in mind, as was mentioned in the lecture on Friday, is that we're also potentially using wind flow in relation to natural ventilation. And so this can give you some pointers as to whether your wind flow will interfere with your natural ventilation, or whether your wind flow may actually help with the natural ventilation. Okay? I mean, I think the overall thing to say with this is this is quite a simple piece of software, but it allows you as a designer to start to understand the wind flow on your site. Now, I think the students are often disappointed because they want it to be the fully accurate wind simulation. And I have to say, well, it's not quite that. It's a slightly reduced version. But the benefit of having that reduced version is you can start to use it quickly. Whereas if you were to run the full CFD package, we'd probably have to spend 10 weeks learning that software and understanding the physics behind that, which is, that's for the engineers. But this gives the architects and the architectural designers a means to start to understand wind flow.